Right. You ready?
Okay.
Okay.
Are we all set? A little housekeeping is in order. I've asked Rick to come up and repeat any question that is asked for the audience so everybody can hear the question, including me. So direct your questions to Rick, and he in turn I'll answer the questions. That's number one. Number two, I'm here to do two things today. I was fortunate enough to take advantage of a scholarship that was put out by the Prescott Area Woodturners, and I went to Craft Supply in Utah for a thread chasing class of 5 days. Let me digress for a minute and say, if you ever have an opportunity to go to a class, go to Craft Supply. They are world-class trainers. Their facility is world-class. They've been doing it for a long time, and I guarantee no matter what level you take, you'll gain a tremendous amount of information. And it's in Provo, Utah. All right, that's the first part. The second part, since what I'm going to talk about as far as thread chasing is concerned, is how to sharpen the tools. The second part of my presentation will be on sharpening generally. And as I said a little before, after that, in March 11th, we'll take actual tools and problem tools that all of you have and work on them so that they work the way that you'd like them to work. All right. By the way, ask a question, raise your hand anytime I'm talking. The only dumb question is the one that hasn't been asked. Before I, okay. Oh, there they are. I was going to say, where are my notes? Right. The first part of my presentation has to do with safety, and safety specifically when you're sharpening. And I put together a bunch of thoughts, and rather than try to guess them, I'm going to read them. And again, if you have any questions, just raise your hand. These safety recommendations specifically apply to using a grinder and sharpening tools. Number one, always wear safety equipment when sharpening. A dust mask, safety glasses. By the way, these are safety glasses, but in addition to that, I brought a face mask and a set of safety glasses that I would normally use. I am going to ask your permission to not use them today because it provides a barrier of communication for me. All right, the second thing, do not use any tool that you're uncomfortable with. Whether I won't go any farther. If it doesn't feel right, don't use it. Find out why it doesn't feel right and then fix it. If you see anything that does not look right, stop. All of the setups that you do should be done with the grinder off and not on. And by the way, that's the voice of experience talking. These are called Raptor tools, and it's a technique for setting a specific angle every time. I had to replace one because I made the mistake of setting it on and trying to set it up with the grinder running. And if you just nick it, you got to get another one. So anytime you're working, well, actually, and that goes with anything, that goes with a lathe too. Anytime you're doing setup, do the setup with the piece of equipment turned off. Practice with it turned off. And when you're comfortable, then turn it back on and grind. Practice all movements around the grinder and wheels with the grinder off. Do not start the grinder until you feel comfortable with the grinder and the techniques of tool sharpening. When sharpening your tools, let the grinder come up to speed first. And that's a nuisance, but do it. Tool sharpening, like turning, does not require force. A soft touch is better than a heavy hand. Remember, the number one enemy of sharpening is the tool handling. And I'll expand on that in a minute. The other nice thing to do is, like with any spinning device, your lathe or the grinder, it's a good idea when you turn it on to stand to the side. Particularly when you're dealing with stone wheels, either aluminum oxide or in this case, this is a ceramic wheel, the white ceramic wheel. That's a brief overview specifically having to do with sharpening. I adhere to all of it. And again, I can't emphasize how important it is. All right. The first part of my presentation, as I said, it has to do with thread chasing. And I just found this the other day. You have to, these tools originally were the only way that you could thread chase. You had to buy a set of tools. When you bought them, they came like this, very squared on the end. What the manufacturer didn't tell you is that they're useless. You can't use them. And the reason you can't use them, and it's kind of hard to see on, can we change? Yeah, I brought 3 sets of thread chasing tools. The difference is the number of threads per inch. I have a 20 thread per inch, an 18 and a 16. The 16 is the most common, and that if you're going to buy a set, that's the thread I suggest. Primarily because it can be used for anything from 1.5 inches on up to large ones. If you're going to do little tiny things, and I've passed some boxes around, then you might want to consider going up. But what I wanted to do, yes, I'm going to take this away, put a piece of paper here so that you can see it better. Now, can you come down on that? Can you get it tighter? Ah, good. What I'm trying to show you is, I'm sorry, Jerry, I'm moving around. I'll hold still. Okay. It's kind of hard to see, but give me that point, give me that piece of steel. Yeah, that. When you get a brand new tool from the manufacturer, there is an extra half tooth here and an extra half tooth down here. That half tooth, when you try to start a chase, will push the tool out of the groove, and you won't ever be able to get a clean cut. So the first thing you have to do is to grind the dickens out of these tools. You grind the end, you grind the half tooth off here, and then I'm going to switch to a newer one. This is a newer one, and there we go. You also put a slight negative rake on the teeth. Can you see it? The reason that I do that is that it allows a little softer touch to the wood. So the tool will go into the wood easier. If you keep that really rigid edge, the tool wants to bounce more. So these two tools, this one, all right. And thirdly, you notice from the original that was straight across, both of these have been ground, the back has been ground off. The reason, and if you notice when you're looking at those little containers, that the thread goes right up to a wall. With the way the tools are delivered, you can't do that. And the difference between the men and the boys when it comes to thread chasing is whether or not you use a relief or not. If you use a relief, you don't have to grind that back. because you have room to pull the tool out before it hits the wall. If you want to run the thread right up to the wall, because it looks nicer that way, you have to remove some of the metal so that this very edge can be removed, can be pulled out before it buggers the last thread. Then, okay, these two are two different sizes. They are 18s and 20s. And this was the first one I owned. And you have every time I put a negative rake on it, if I don't lower the back of the tool, the rake gets steeper and steeper and steeper. So you keep grinding the tool down. Believe it or not, the narrower the tool is up here, the easier it is the better it is to cut threads. You reach a point where you're just too thin and then you've got to replace it. That's with these tools. Now these tools, I can't remember, but I think they run about 110 or 100, around $100 for both of them. The outside thread, the male thread tool, is ground differently. It has, as you can see, it has a negative rake. You want me to move? There we go. It has a negative rake on this side, but you notice there's an area, a relief area that's ground on the left side. The relief area is for the same reason, so that on the outside, when you're cutting the male thread, you can run up to the edge and remove it. If you don't do that, the other alternative method is putting like an 1/8-inch groove, which then allows you that gives you the space to pull out. So if you buy this type of tool, there's a significant amount of grinding that goes on before it's useful. And interestingly, maybe it's just me, but I've never heard a manufacturer talk about that. I learned this from Craft Supply. On the first class I took at Craft Supply. We all bought new threading tools, and the instructor said, "Oh, you got tools? Okay, we're going to have to fix them." I said, "What do you mean fix them? I just bought them." Well, he explained why, and by the way, he also demonstrated that he couldn't get a thread started with a new tool. All right, now let's fast forward. Carter and Sons, with the help of one of the very well-known turners, and I can't remember who it is right now. Mike Mahoney designed a double-ended thread chasing tool, which is slicker than you can imagine. This tool works out of the box. There's a couple of modifications. By the way, it also comes with a negative rake. This tool is made out of M42 steel, and M42 steel is the latest in metal concoction that provides a sharper edge for a longer period of time. It has a male side and it has a female side. Now there is one modification that was made to this. As the tool comes from the factory, it is straight on the edge, which again gets in the way if you want to run the thread right up to the wall. So all I did was just ground off, made it round so that now I can get right in there. This is if you're going to buy a tool, I highly recommend this. It's, by the way, about the same price. And I was dubious when I first got one of these. I thought, okay, here we go. We're going to have to grind forever. And I just took and I turned it. I put a thread on a piece of wood just like that. And I go, wait a minute, why did that work? So I highly recommend this. It's comfortable to hold. It's all in one piece, and it takes very little grinding. You again want to sharpen it occasionally, but again, it's a matter of how much you're going to be using it and what kind of wood you're trying to put a thread in.
Hold on a second. Yes. He asked you is, with the hand tools, you have to use very hard wood. Is this capable of dealing with
That's
that?
a really good question. And I won't go far into it, and I'll talk to you later about it. But yes, there are woods that will hold a thread, and there are woods that won't. The softer the wood, remember, you're putting little tiny ridges in straws. So unless the straws are really close together, they break off very easily. There are ways to modify that. CA glue is one, lubricant is another, and there's a whole bunch of different things. But there's a cadre of about 7 woods that work extremely well for thread chasing. You'll notice the pieces that go around here. Those are good examples of the type of wood. Any other questions?
Did you have something else? It wasn't actually a question, it was a statement, so we're good.
Okay. Are there any other questions having to do with threading? Rick and Bruce went into detail as to how to chase threads, and I don't think it's necessary for me to do that. Yeah? I'm sorry?
Will you be showing them how to sharpen those threading tools?
Yeah, the sharpening of a threading tool is only redoing the negative rake. That's it. You don't touch anything else on the tool. And with the M42, I've chased a lot of threads, and I have yet to resharpen it. With the other ones, yeah, you have to keep up with those.
Any other questions? No.
Okay, good. All right, this can go away. I think do we want to move this, Jerry? Yeah. Excuse me for a minute. We're going to do a little modification. Okay.
I'll get it.
More. We're positioning the grinder underneath the overhead camera. Oh, I thought I heard something going on. Then where's that noise coming from?
Your nose.
Yeah, that's okay. As we get going here, if you see a better angle, just say so and we'll move things around. Okay. You good? Yep, I'm good. Fine. Fine. Okay. The general question is, why sharpen? Somebody, why do we sharpen? All good reasons. What's the objective of sharpening? The sharper, the better the tool, the less sanding is done. Okay. We're going to talk specifically about sharpening that has to do with wood turning, not sharpening in general. You can get a good edge on any piece of steel you want if you're willing to spend the time and the effort to do it. So there are no bad systems. There are systems that work better in certain circumstances. 3 types: wheel, belt, and hand. We're going to be dealing with wheel sanding mostly. The belt sanders are interesting, and yes, you can do it. And yes, they do give you a fine edge on a straight piece of steel or on a knife. But in my opinion, they don't lend themselves comfortably to sharpening a gouge. And a gouge is a central piece of equipment we have for wood turning. So that leaves us with hand and wheel. I personally do not want to spend the time and the effort trying to sharpen one of our tools using a hone or using a diamond or anything else for that matter. The reason basically is time. The longer it takes to sharpen something, the less you're going to sharpen it. End of story. The quicker you can do it, the faster you do it, the more you'll do it. To me, the advantages of using a wheel far outweigh the advantages of using anything else. There are basically 2 types of wheels we're talking about, 2 types of systems that we're talking about that use a wheel for sharpening. The Tormac is one, and the Wolverine system is the second one. Again, there are a lot of other things out there, but when it comes to sharpening a bowl gouge, there's basically two systems that will give you an edge that you want in a reasonable amount of time. Now, in addition to that, the technique for sharpening between these 2 systems is significantly different. And some people swear by them, by one, and some people swear by the other. I'm going to go through what I look at when I'm trying to sharpen. And specifically, the Tormac is a large 10-inch wheel, typically a wet wheel that moves at a very slow speed, slow RPM, that will sharpen anything you want, but particularly things like planer blades and chisels and stuff like that. It'll give an edge far beyond what anything else will give it. They also sharpen bowl gouges with series of holders that they have. The issue that I have is that the Tormac system is very expensive and complicated to use, in my opinion. Maybe somebody disagrees. Complicated to use. Okay, let me stop here. When anybody talks about anything, they should talk about biases. I have biases. My bias is that I don't like to spend time on a grinder. I want to spend time on my lathe. And if I have to spend time on my grinder, I want to do it quickly. I want to get it done. And because I'm spending a lot of money for my tools, I don't want to take a lot of time because time equals metal off the tool. The longer I'm on the grinder, the more metal I'm taking off my tools. Just aside, I had HHS steel bowl gouges, which I really liked, and they came out with M42, and I had tried the M42s, and there was such a difference between the 2 of them. But I had a real problem. The way that I grind, I take very little metal off, and consequently, I was never going to outlive these gouges. So I decided I'd just give them away. So then I bought my M42s, which I'm very happy with. But the bottom line is, if you buy an expensive tool or a quality tool, you want to keep that tool as long as possible, which means that you want to take as little metal off the surface as you possibly can. In my opinion, okay, the Tormac will do that, but it takes a lot of time to do that. The other system that I recommend and I use and I prefer is called the Wolverine system. And it's this system that is here. It has 2 holders, it has a V-arm, and it has a platform. And it has a holder. those three things allow me to set up and sharpen and go back to the lathe. All right, that's my bias. Right now, I'm going to back up and talk a little bit about. Let's talk about grinders themselves. Any grinder that you use that has a wheel is going to give you a convex cut on your bowl gouge. And the object of a bowl gouge, or any other gouge for that matter, is to rest the bevel on the wood. So the larger the convex here, the less metal you're going to have on the wood, which brings us to a point of, if you use a 6-inch grinder, that convex is significant, so that the only two portions that are touching the wood are the heel and the head. So we're settled on an 8-inch grinder. You can get 10-inch grinders larger, but again, they're commensurately more expensive. So the average grinder that is in a wood turning shop is an 8-inch grinder. That 8-inch grinder uses two wheels. The wheels can be ceramic, they can be aluminum oxide, or they can be cubic boron nitrate, CBN. The state of the art of grinding and wheels has come to a point where the CBN wheel is hands down the best wheel to use. One of the main reasons is it does not reduce in a diameter over its lifetime. So if you do set up for specific angles and for specific distances, they stay the same. If you're using a ceramic or a aluminum oxide wheel, you have to continually change these dimensions. So anytime you change anything, you use more steel. In addition, I'd like to comment, we have a white wheel on here. This is a ceramic wheel. Ceramics wheels are very soft and good, you got the overhead camera. Can you zero in on, you probably can't. There's a groove in this wheel. And the reason that there's a groove in this wheel is because somebody attempted to sharpen a turning tool on it. The ceramics will give way to stainless steel. It'll sharpen them, but it'll take this down really quickly. And they're relatively inexpensive. If you wanted to stick with aluminum oxide wheels, the wheel of choice for wood turners is called a Norton 3X, which is their own concoction, but it works extremely well in holding its own and also sharpening tools. They come in a 36 grit, which works very well when you have to profile, and I'll explain what profile is in a little while. But let me go back to the CBN wheel. One of the biggest problems that you have with a grinder is vibration. Stone wheels typically are not, they're not precision balanced wheels. They're a mold. So they are inherently unstable. You put them on a grinder and turn them on, and you all know what happens. You hear all this noise and all this vibration. Well, the problem with that is you can deal with it, but the moment you try to put a tool on it, the tool's going to bounce like this, and you're not going to get a smooth, even cut. So people go to great lengths, and by the way, I won't go into it at this meeting, but I know how to balance stone wheels, and it's a process, but you can take most of the, probably 85 or 90% of the vibration out of a stone wheel with adjustment. It's a procedure, and if anybody here would like to know what that is or has one, I'll be happy to in fact, I'll go to your place and show you how to balance it. With the CBN wheels, they're machined. You take a CBN wheel and slap it on your grinder, and that's what you hear. Imagine how much less of a challenge it is, number one, to set your grinder up, number two, to use it, and also to establish the specific parameters for a specific angle, bevel angle, 45, 50, 60, whatever, up to about 60 degrees. Once you get beyond that, then you use a platform, but I'll go in detail. So, okay, let's talk about any questions up to now, even if they're far-fetched.
What grit wheels do you use?
Good question. There are, let me put it generally. You need a very low grit for, all right, might as well do it now. Can you, okay, where are we? All right. What you're looking at here is a profile of the turning tool. That's a profile. If you notice, to get the maximum amount of steel onto the wood, it has to be sort of a curved surface. That's the surface up here. This shiny surface in the back is the bevel. There are a lot of tools that when you get the tool, it just doesn't look right. The profile in a good turning tool has a stooped nose. Oh, it's hard to see. Oh, there we are. There we are. You see how it kind of goes down the front? The first thing you do is to pick up a tool and look at it. And if it doesn't have that profile, it doesn't have a nice stooped nose, you have to fix it so it does. And that function is called profiling. Now I'm getting a little aside, but the first wheel you need is a wheel that is fairly rough. For example, a 36 grit. It's because you need to take a lot of steel off your tool. And what you do is you turn this tool directly, the flute flat against the wheel up here and put it on and then pull it across. So basically, I'm grinding the whole top surface. And I keep grinding it until the thickness on each side of the flute is the same. And I have this profile. Then I proceed from there. I start with a 36 and take remove a fair amount of the steel until I get close to a sharp edge. And at that point, there are three different grits that I suggest. One is a very rough one, for example, a 36. The next one is around an 80. And the interesting thing about the aluminum oxide wheels, if you have an 80 grit, you have an 80 grit forever. If you have a CBN wheel, CBN wheels tend to round off a little bit. So instead of, you buy it at an 80 grit, but it will end up being slightly less aggressive, maybe 120, which is true for all the CBN wheels. I would recommend a 36, a 120 or a 180, and a 300 to 400. And the reason is because you use the heavy grit one for profiling, the medium grit one for removing the material fairly quickly, and the fine grit for putting an absolute razor edge on. Now, you know that any tool that you get, when you put a razor edge on it, the razor edge is really not a razor edge. It's a scalloped edge. It's just the function of how big the scallops are and how well the steel can hold the scallops in place while you start to cut. So in obtaining that angle, there are three things that are required. And you want to hold them all as accurately as you possibly can. The bevel, we talk about the bevel angle, which is the angle that you rest against the wood. ABC. What's that stand for, John? Bevel, 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 bevel. All right. The reason that there are different bevels is because it allows you to hold the tool differently for different types of cuts. There is no one perfect bevel for everybody. There are average bevels, and coincidentally, I use the average bevels, but there are arguments for using other bevels. For example, for my bowl gouges, I use 45-degree bevel on all of them. There are other people who use 40. There are some who use 50, and so on. But the reason for the different grits is to, one, obtain speed, and two, the loss of material, minimize the loss of material from your gouge. All right, where am I? We talked about, we talked a little bit about bevels. Talk about the average, the typical grind that we use for bowl gouges is called a fingernail grind, and there are basically three different grinds. One is a standard, which is if you measure the width of the flute, and then whatever that dimension is, you come back one for what's called a standard. You come back 2 for a fingernail, and 3 for what they call an Irish grind. An Irish grind is typically used for doing a lot of shear scraping. It provides a lot more surface for keeping your edge sharp, which is the whole idea. Okay, now we want to talk about, wait, it's any questions? Am I zipping along? Chuck. To me, the swept back just means some type of a fingernail grind. The Irish is very specific, and there are several people who really swear by it. And again, none of this is cast in steel or in cement, either one. It's whatever you feel the best is, whatever you like, whatever makes you turn, makes you satisfied with what you're turning. I happen to use 45 because of the first class that I went, which was craft supply. They use a 45-degree bevel, and they use the Wolverine system, and they use this gadget, which is called a Varigrind, but basically it's what holds the tool. If you want to minimize the amount of steel that you lose each time you sharpen, you want to have a fixed, you want to have an anchor that is set up very specifically. And in the case of the Wolverine, it's a 2-inch protrusion over the top, which I'll use this right here. That's 2 inches. And then a specific location for this V-groove. All right, how do I get there? The easiest way is to use one of these. These are you can make them, but you can also buy them. But to me, this is an absolute necessary you have to use it with a Wolverine. And if I do that, this is a 60. I just put in, there are 5 of them. They come from 35 degrees up through 60. And what I'm looking now is 45. I take this, put it in a V groove, move it up to the tool, and mark it and lock it. Now, every time I go to the grinder, if I have a 2-inch extension here, and I have this, I can mark it in the exact same place. When I put this on, all I have to do is to go back and forth maybe once or twice. And depending on whether you're left-handed or right-handed, it doesn't make any difference. But you start on one side, go to the other side, do the other side, and then you do the tip first. Now you notice where I'm holding the tool? I'm not holding it back here because it's, you try it, it's really awkward. I get a tremendous amount of movement. What I'm trying to do is to keep my movements at a minimum. So I move my hand up close to the tool and I hold the tool. I go on this side, turn it over, this side and back. Now, just in case there is, if you go to somebody's house and they have a particular grind and you like that grind, or somehow or other you just came across the grind, but you want to repeat it. The way you repeat it is to take a magic marker, mark the end, and then adjust whatever you have. Turn the wheel by hand. And this is set up so that I'm not there. I'm hitting the base, which means that I'm too close. So if I back it off a little, it's way off. There. Now I'm repeating the grind that's on the tool. And a lot of times you'll find somebody who has a tool, or you'll use a tool, or you'll regrind your own, and you'll find you really like it, but you don't have any perfect way of setting it up. That's what you do, is you just repeat it by blackening the bevel surface and adjusting your holder until you actually scribe from the base to the tip.
Question.
Yeah.
Yeah. The Varigrind has notches on it where you can set it to different angles. Which one do you set it at?
Very good question. Moving the post changes the length of the fingernail grind, one way or the other. I learned from the very beginning that the average swept back that it gives me all that I want is set for 22.5 degrees. The way you get 22.5 degrees is, where's the gentleman that I gave it? Okay, hold that up. Show him how I got it. That's a 8.5 by 11 sheet of paper that's folded twice. It's folded once to 45 degrees, and once the final fold is at 22.5. What you do is you take the Varigrind, excuse me, let me do it up here on the, here's the Varigrind, and I'm putting the piece of paper parallel to the turning tool. And if you'll notice, the post matches that angle. This is the angle that Craft Supply uses. And by the way, my apologies for keep going to Craft Supply, but I've had 11 classes with them, and everyone has been just absolutely perfect. They have something for everybody, and they do a great job. The first time I went there, I picked up this Varigrind, and it looked just like this, except for one thing. They had the post welded. They had people moving it around. They said, aren't going to do that anymore. So they welded them all. Well, I've never welded mine, but I've never changed it either. So with a 2-inch protrusion and a setup based on the Raptor tool, my tools are sharpened very quickly, very accurately for each time. Okay, let me talk a little bit in general. How am I doing on time? I don't want to run too far over. I got a lot of information. What time is it? How long have I been doing this? Perfect. Okay, let's just do some nuts and bolts. Let's talk about different angles for different types of turning tools. Remember, the angle is not cast in stone. It can be whatever you're comfortable with. I'm going to talk about what I use, and I use what is average. We've talked a lot about the V-arm. Let's talk about the platform a little bit. And one of the tools that people sometimes have a challenge with, and that's a skew. How do you sharpen a skew? Well, you probably haven't noticed, but on all of my tools, I've written what the bevel angles are in both cases. So I don't have to remember what it is. I can just look at it. In this particular case, this is a double bevel. There. You see the two bevels? One is the sharp edge is here, and then back about 1/4 inch, there's another bevel. The difference is the one on the top is sharpened to 15 degrees. The lower bevel is sharpened to 20. The reason, okay, this is personal preference, but the reason it's done that way is in order to use a skew, you have to be on the bevel before the blade touches the surface. If you don't, you're going to get a run out. So if you touch the bevel first, now you've got a steady point. When you bring the bevel up to cut, you've got a support. In order to sharpen this, we use the platform. And in order to use the platform, I use a series of these little gadgets. And I'll pass this around. Most of you know what these are, but they're a series of angles that are used to set a specific angle on a platform. I use that, but in addition, whenever I'm sharpening the skews, I also use a black marker because that gets me close. But if I don't use the black marker, I end up changing the entire blade, entire edge, and I would rather just be able to touch it up a little bit. Now, is the place in Turner's Emporium, are they still in business?
They're a mail order now, and
They're what?
they're a mail order now.
Oh,
And if you buy two, they give you the other one free.
hey, that was the only place that I know that had them. They were invented by Stuart Batty when he was manufacturing tools. He's since out of the business, and the Turner's Emporium people bought all of the materials. So I don't know. I think they're still available, but I don't know for sure. Anyway, when you're sharpening, when you're using the platform, again, you don't use the handle, you use the knife. And it's a process of moving one way, bring it over, moving the other way, keeping the edge dead center on the skew. I'm sorry. Just yell at me when I'm not doing what I'm supposed to be doing. I turn this way, turn it back, and turn this way. Now, whenever I resharpen the edge. I don't touch this secondary bevel until it gets down fairly close. Then I'll redo the bevel. But basically, I want to just go for the edge. Roughing gouge. On this one, I use, excuse me, I use 45 degrees. Now, some people use a lot steeper, but remember, the object is to get on the bevel first. Think about this. 45 degrees is here. If it were greater, the farther down my tool goes. Well, you reach a point, and it comes up pretty quickly where when you try to go across, you hit the bed of your lathe. So when you have your tool and you have it and you're going across the piece, and your tool hits the lathe, you've got to do one or two things. If you want to stay on the bevel, then you need to change the bevel. Yeah. A very good question.
What is the profile on your rough
Yeah,
and gouge was the question.
It's straight across, which is not easy to do. When you look at it, you go, oh, all right, the way I'm going to sharpen this is I'm going to put it down, I put my thumb on it, and then I'm just going to go across one side and across the other. The problem is there's more steel in the bottom than there is on the edges. And if you do that each time, you'll find that these two leading edges will start going back. So in order to sharpen a rough and gouge, you sharpen it on the center first, the center 1/3. Then you turn it all the way over to 1/3 on the side to where you just finished the middle, and 1/3 on this side. Maintaining this perfectly flat period across. There's a couple of reasons for doing that. Some people want to sweep back these two edges, but this is an incredibly popular and versatile tool. If you have nice, clean, sharp edges on the side, you can face off the piece that you're doing on both ends very quickly and very neatly. And you can get more accurate cuts that way. So it's don't just put it on it and go all the way around, because you'll find out these two edges are going to fall down. But it's, to answer your question, Dean, it's perfectly flat all the way across. Let's talk about bevel angle on bowl gouges. This really has to do with wood turning, but it also has to do with sharpening. To go inside a bowl from the top to the dead bottom is a parabolic, more or less parabolic experience. To do that, you have a tool that has a particular grind, a fairly medium-sized grind, like a 45. When you start down the edge of the bowl, you reach a point where it won't go any further because the bowl is turning this way. So you have two choices. You have a choice of buying another tool and grinding it with a steeper bevel angle, or taking the same tool and going back to your grinder and regrinding it. As you come around farther, all of a sudden that particular grind won't work either, because now it's almost leveled out, and you to stay on the bevel, you can't stay on the bevel. So what do? Well, go back to the grinder and grind it flat. Or you take a third tool and you sharpen the third tool so that it will go down that way. The issue here is, how long is your one tool going to last, and how much time does it take to do all that? So I like to have a separate tool with each one of the different bevels that allow me to go from the top of the vessel to the bottom of the vessel. And for me, that's 3 different angles. It's a 45 to start, it's a 50 to make the curve, and it's a 70 to go across the bottom. And this is a 70, and I'll pass it around. That's called a lobotomizer. But what it will do, it will create a finish that does not need sanding. It's tricky to use, just like the skew is tricky to use, because you have to be on the bevel before you touch the edge to the wood. If you don't, off you go. And it's not forgiving. But if you're on the bevel, it does an amazing, amazing cut. Do I have what? No.
Do you have a winch
No.
while you're holding on to this?
You know what? Believe it or not, it seems bulky and awkward, but because of the type of cut that you're making, heft really helps. Helps to hold the tool down, and it just does a great job.
Spence, a question from Dean.
A lot of turners have done this, but I took mine and polished the heck out of the platform. Took some sandpaper, I put it on my orbital sander, sanded it down and polished that so that when I'm turning, there's less friction and catch.
Yeah. You're speaking about that, Dean.
Hold on. What Dean just said was that he polished his platform, so when he's sharpening, there's less resistance.
Thank you. You just reminded me of something. When you buy a Wolverine system, this platform is welded, and it is deformed. It is not flat. And you should take a file and file the whole top surface. Otherwise, believe it, there's a significant bump in the middle. They make an auxiliary or a platform that I like occasionally that fits the Wolverine system. It's just a little tiny one. And the neat part about this is, if you have a tool that's been used a lot and you still like it, this gives you another inch or so worth of support. Plus, it's got other uses. Okay. Any more questions?
Question on your gauge. So you sit around or adjusting your platform angle, the Stewart Batty gauge.
Yes.
They do that. Can you use the Raptor to adjust the platform angle?
Yes. In some cases, yes. And I'll tell you how.
Let me just
I'm
repeat
sorry.
that.
I
The
did
question was,
recognize
can
I
you use,
apologize.
can you use the Raptor gauge to adjust the platform angle?
Did you all hear that? All right. There, as I say, the Raptor gauges, they give you 5 gauges from 35 degrees to 60 degrees. Each one of those has a flat platform adjustment where you just lay this on a platform, set it up. Now that is a 60 degree, and if you're doing a flat work, it works fine. The challenge there is it only goes up to 60 degrees, and most of the platform work that you do, with the exception, by the way, of the roughing gouge. I'd use one of these for a roughing gouge. But for the skews and for the very pointy things, you have to be up in the 20 to 15 to 10 degree. And the only thing that gets you close is that. However, if you don't have something like that, then you take the tool that you have that has that angle, black in the center, position it on your platen, and adjust it until you just hit all the way across the surface. You're back to the same point. So you don't need any money. Speaking about money, the other thing I didn't mention with regard to the Tormac versus the Wolverine, the Tormac with not all, but several of the gadgets is in excess of $1,000. With all the gadgets, the Wolverine system is less than 300. So I would take the extra money and buy 2 CBN wheels. If you have a Wolverine system and 2 CBN wheels, and by the way, either a slow or fast grinder, you're fine. And you're going, wait a minute, you can't do that. You have to have a slow grinder. That's true, because friction creates heat. If you have a stone and you put metal to the stone, you create heat. To reduce the heat, what do? Slow it up. CBN wheels do not produce anywhere near the heat that stone wheels do. So you can run a 3450 without any problem at all. It really frees you up for a lot more opportunities to buy stuff. Okay, last thing, and I want to change this. I've been doing this sharpening for a long time, and I don't know why. In the very beginning, I thought, why am I doing this? What is all this business, and why? So I spent a fair amount of time experimenting and trying different things out, and came up with a system for me that works really good. And as I said, that's a CBN wheel, a Wolverine system, and it was working fine. Some time ago, and this is not my idea, this is Dave Madden's idea. He told me about a system that he uses, and I thought, oh, okay, I'll give it a try. Guys, this is homemade. It's a piece of 1-inch PVC. That I slip on here, tighten it up, and then taking my Raptors one at a time, this is the 60 degree. Supposedly it fits mine. The reason that there's variability, by the way, is because these holders are never in the same place, either height or distance or width or anything else. So each one is unique to your particular grinder, which is okay. You cut a piece of PVC that when you take a 60 degree Raptor and put it in here, it matches. So that you know is 60 degrees. So if I have a tool that has a 60 degree on it, I put the, this does it. But now I have a fixed position and I go and I grind it. Okay, now what I do is take all of the other Raptors and measure the distance on this piece for wherever one goes. And then measuring this distance, I make a block. Then I have 4 blocks here. If I want to sharpen a 40-degree, I put that in there. Take my tool, lay it in here and sharpen it. If on the other hand, I have a 35 or 50, I've got blocks for 35 through 60 degrees. And this is permanently in position. And for me, I got to tell you, I've been turning for a long time. My frequency of turning went up at least a factor of 2, probably 3. Because all I have to do is to turn the grinder on and go back and forth once. And believe it or not, one pass is a totally clean, pure cut. So A, I'm more than twice as fast in the setup. B, taking far less steel. And again, this is Dave Madden's idea, and I swear by it. It's the slickest thing since I've started turning. And the bottom line is, it doesn't limit my grinder, because if I want to do something else, I just take this off, put this in, or a platen or anything else, and when I'm going back to my turning, I'm at exactly the same point with these little blocks. I can't, as you can tell, I can't speak enough about it. It's the slickest thing since I've ever used. And most importantly, it's helped me as a turner, because now you can imagine, I sharpen pretty frequently normally, but I've at least doubled the amount of time I go to the grinder, because it's no problem. There's hardly any setup at all. In fact, there's no setup. Once I've got this in place and I'm using a bowl gouge and I'm using a 45 degree, I just go back, put it in the holder, and I'm done. So you make them up individually on your own grinder, because the distances are different depending on how you mounted the holder. Question back there.
He's saying the CBN wheels come from 30 all the way up to 600. What is your recommendation for the grinder?
A medium aggressive and a medium fine, meaning anywhere from 120 to 140 to 150 on one side, and then a less aggressive wheel on the other side. 250, 300, 350, whatever. I'm not sure how they are marketed. In my shop, I have an original 80, which is probably 120, an original 230, which is probably closer to 300, and an original 400, which is now probably 600. And the only turning tool that I use the fine one on is this little spindle gouge. I keep a very sharp, very fine point on it. Now, the problem is, the sharper your tool, the quicker it's going to dull. End of story. So there's a trade-off here. How sharp do you really want it? And what are you going to do with it when it's that sharp? For me, this little spindle gouge, it's got a 35-degree bevel. It allows me to do small beads and get into very small areas. I'm not there very long, so I can afford to have a super sharp tool that's going to dull fairly quickly, because it'll allow me to make the cut where I don't have to sand. I've covered just about everything I have in here. Are
Spence?
there any other questions?
Yeah, John, what's your question? How do you clean your CBN wheels?
2 ways. There is a commercial eraser that you can buy that you just go all the way around. Or the other way is a little soap and water with a stiff brush. That seems to work as good as the eraser, but it's a little messier. It's a good idea to clean them, but the bottom line is I don't do it very often. I probably should, but I don't.
Curious if the public could, just like the sharpening wheel is like $100, then you jump up about $50 to the higher end one, UA tool or Woodturner Wonder. I'm curious as to the difference at $50 if it's worth it or not.
He said that there's different qualities of CBN wheels. And do you feel that it's worth the extra $50 to jump up from the lower price CBN to the upper price?
I'm not a metallurgist. CBN wheels are CBN wheels. I think the difference is in their design. There are thin ones, there are fat ones, there are round ones. If it were me, I would find the least expensive CBN wheel I could find and use that because it's the same material and it's held on the same way. Aside from that, the other thing I would try to do, guys, I know it doesn't make any difference and I know it's fine, but having a bare wheel sticking out like this makes me nervous. It just does. And I have no reason to say, I've never gotten hit by anything. And these particles are not supposed to come off the wheel. And, and a lot of people use them this way. But personally, I made an effort to put mine inside the case. Now, I had to put washer spacers to move it out because it was wider than the standard width. But I feel much more comfortable doing that. And in addition, when I turn, whether it's left-handed or right-handed, I could do it on this one. It's important to steady yourself when you're turning. You need some kind of support for your hands, or you should have. You can, with a wheel like this, just get it up here like this, and you can do it this way and this way. But personally, I prefer being able to rest my hand on the case, on the outside case of the grinder, put my thumb. How am I doing up there?
That's better.
There. Put my thumb here for two reasons. One, I have way more control in both directions. But in addition to that, I can feel the steel getting hot. And I can stop grinding much quicker than if my hand is back here. Now, from a safety standpoint, I'm not advocating which way you do it. I'm pointing out the differences. There are people who prefer to grind like that. But personally, I'd rather have one hand on a tool, the other hand on a steady surface, allowing that hand to provide guidance for where I'm at. And that requires the shield to be on your grinder. Again, personal preference.
Any other questions?
I have a comment. I learned the block system that Spence has told us about,
You can pass that around. I should have
Okay.
passed it around.
but I just wanted to demo that. And he has them marked. I learned this in his workshop and Spence's workshop. Since then, Rick made some, I made some of these, and I think Zim or somebody. Anyway, I'm gonna pass these around.
They didn't work.
But they do work. I'm gonna give testimony. I like them a lot. So they save me time, but more importantly, they save the steel on my tools. So the key here is keeping the angle consistent. Because what Spence has told us about using the Raptor tool, yes, that gives you the angle, but your angle might be just slightly different each time you use it. when you go to set it up. With those blocks, you can be much, much more accurate and keeping that angle just right at the angle that you looking for. So it works. Ken has a question. I used hardwood myself. Oh, okay. The question is, what are the blocks made of, hardwood or plastic?
Hardwood. The hardest wood you can get, because you don't want any give anywhere. It needs to constantly stay the same. The ones that I made are made out of Wingate.
And the ones I made are from carob, which is another pretty hardwood. John?
Steep would be ideal because it's hard, especially the hardwood. Wood, hard and has very little movement.
That's
Said
really important.
Mesquite is what he uses, John, because it's hard. And what was the other reason? There's no movement.
Yeah.
Yeah.
Like
Yeah.
mesquite's would be a great wood to make it out of.
Now, what, did you put magnets in yours? Did you put magnets in yours?
Did I do what?
Magnets.
Magnet? No,
okay.
I just set them in there.
Well, Rick put some magnets on the backside of the piece of wood. When he puts it in there, it just adheres right.
Yeah,
up to
that's
the
a good
top of it.
idea.
So it's a good idea. I have not done that with mine yet, but I think I might. So
I have one other little thing I'll talk about for a second. Those of you who have hollowing tools that use very small pieces of tool steel, kind of like this. This is a 3/16 piece of square tool steel that was sharpened with a 60-degree slope on it. And it goes into what we call a toothpick. It's a piece of steel with this on the top. And it really helps in hollowing. Well, you can tell, they're kind of hairy to sharpen. Well, we invented this little gadget. Can I do that? Anyway, these are homemade. We just took a piece of cold rolled steel, drilled a little over 3/16 hole in the end, tapped it, put in a little rod. This rod is 7 inches long. The dimensions here are specific, but you measure from this edge out 2 inches, center punch it so that this will stand on the edge, and then another. I got it on here, 2 inches to here, 4 inches to this point. Lock it down. You set this in. You put this in. Like this, crank it down. You set this in the little holder, and then it automatically gives you a 60-degree. And because, although this is tool steel, it dulls fairly quickly. So you have to keep sharpening these things all the time. And I could tell you from experience, using your fingers to do it is a little hairy. So there, I'll pass this around.
Do we have some questions? Okay.
Bill Cram wants to know what the thicknesses of the blocks are so that he could make his own.
You have to make your own, and I can't tell you what the thicknesses are. The thicknesses will be a function of the Raptor tool, the V-neck, and the location of how the V-neck is anchored. So each will be unique. My set of blocks would not work on your grinder. It won't work on this grinder. But once you've made this extender arm for your grinder, from then on, there's no changes.
Will you say again, Spence, what the initial dimension is based on?
60 degrees.
Thank you.
And the reason it's 60 degrees, guys, is because that's the biggest, steepest bevel that the Raptors come in. Then you do two things. One, you use that little gadget that I showed you, or if you already have that pretty close on your tool, you mark your tool and move the platform around until you got a perfect match.
The question was, what if you want a 70-degree angle? And you
Right.
answered it.
Okay, I beat you again. I apologize.
No, it's okay.
But you actually, you do one of two things. You get the approximate angle by using that little jig that allows you to set the platform at 70. But I guarantee it's an approximate setting, and you can use that, but every time you use it, you're going to take a lot more steel off. You put it almost at 70, mark the tool, put the tool on, and then just move the platform enough so you get a perfect clean, and then you do it.
Any other questions? Ken, you look like you're itching back there.
Basic, but use the converting tool, 20 degrees, using the platform. You had a curved skew, but a straight across skew.
Yeah.
Presenting that to the wheel and also the parting tool, you know, how do you present that tool to the wheel to get that nice, even straight edge?
Ken's asking, how do you get the correct edge on a skew or a parting tool?
I'm not sure I understand.
It's how do you present a skew or a parting tool to the wheel so that you get the correct angle on that?
There's two answers to that question. The first answer is there are two types of straight edges that are skews. I mean, two types of skews. One has a straight edge and the other has a curve. It turns out that the straight edge skew, in my opinion, is a lot, well, let me go the other way. The curved edge skew is a lot more forgiving than the straight edge. And you have a little bit more control about where you're actually cutting. Because with a straight edge tool, as you go along, you get dust almost 2/3 of the way down. With a curved tool, the only place you get dust, is that's what you're looking for, is right where the tool, the narrow point that the tool is cutting. In both cases, you set the angle 10 or 15 degrees on the platform. And the way you do that is you go to your original tool, blacken one side, put it on the platform, and then move the platform around until you're just grazing it. Go ahead.
When you present the skew to the wheel, are you moving it across the wheel or just touching
Yes.
the wheel?
Well, two things. You're moving it across in both cases. In the first case for a straight edge, you'll hold that angle and just move it straight across. In the case of a curved, as you start here, you start at what's called the foot and come across, and it gives you arc it across.
How do you compensate for the fact that if you're moving it to the right, the left side of the skew is going to be on the wheel longer than the right side?
The way you compensate for that is the amount of pressure that you put on the tool itself. Granted, you're absolutely correct. On both ends, there's less steel on both ends than there is in the middle. So you start with light pressure, medium pressure, light pressure. Did I come close?
With the parting tool, since the wheel is curved and you present that cutting edge, are you bringing the cutting edge back down this way or presenting it to the wheel and moving it forward?
Now, when you're saying parting tool, to me, grinding a parting tool is totally different than grinding a skew.
Okay.
Parting tool is a thin tool that allows you to cut pieces of wood in half. They're only about, they can be an 1/8 inch, and they're usually 3/16. But this is a skew, and this is a skew with a curved edge.
That one I understood the sharpening process.
I'll tell you, with the parting tool, it's a good question. Let me try to answer that. Parting tool typically looks like this. With this edge being the edge that you use to go into the wood. This is bulky, and I prefer a different profile. My profile for a parting tool looks like this, with this edge being the cutting surface. Yeah. And this edge, they're coming up. I'm a lousy drawer. But basically, I want as little material as possible to get to the wood. Okay. Yeah, the one that's got fat sides on it. And how do I sharpen that? Basically, it's the same way. It's about like that. And there's a specific reason why I do this. The object is to get the wood, in all the turning, is to get the wood away from get the chips away from the wood as quick as possible. If you make it straight like this, the chips are gonna push off this direction, and there's more resistance for the wood being removed than there is if you provide a hollowing area behind the actual blade. Sharpening a diamond-shaped parting tool is not easy to do. It's really difficult. That's why most parting tools that you see have straight sides. That lifted center portion makes the tool unbalanced when you try to sharpen it. And so, John.
Grab anywhere.
Yeah.
Basically, you can either put it down into that arc. He's talking about moving it in or out because the tool is too big or the tool is too short.
Oh.
You have a longer tool, you can just lay that on and bring that up to that bevel if it's set up properly.
Making sure that
Both sides.
making sure that the burr is on the top, guys, by the way.
Can you talk a little bit about the burr and where it should be and how you should use it during cutting and sharpening?
Good question. Let's say, let me do this. Told you I'm a lousy drawer. Let's say I have this arrangement. There's two ways I can sharpen this, actually. Now, let me go back this way. There. There's two ways I can sharpen that. Either this way or this way. And I would use the profile of the wheel, by the way, to get this curve, whatever it is, an 8-inch. But if this is the top of the tool, let's talk about this little area here. If you put the grinder here, is going to create a little, I'm exaggerating it, a little piece that comes up like that. That's called the burr. And this piece is what removes the wood easily. However, it's very tiny and it doesn't last very long. So you've got to keep going back. But what the point I'm trying to make is that with any flat tool that you're getting, with the exception of the skew, the burr needs to be on the upside because that's the side that does the cutting. If in this case you sharpen it on this side, which is the top, the burr would be going down here. And it wouldn't cut anywhere near as well. Speaking about the burr, if the wood that you have is relatively soft, you want a very large burr, one that you can see it. If the wood is very hard, like hard maple, you want a very small one. But the whole purpose of this thing is to reduce the amount of sanding that you do. That's the whole purpose. So anything you can do to improve your cutting so that you don't have to spend so much time with sandpaper is to your benefit. But unless there's any other questions. You know, John, yes, I do.
The question was, does he hone his
Oh,
skews?
thank you. And I'll tell you, there's a lot of discussion, but the bottom line is with a skew, you want the absolute smoothest, cleanest, sharpest edge you can get. And no matter what you use to sharpen your tool, the last stroke you put on it is going to put a burr on the other side, no matter how light you are. The challenge with that is if you're cutting in one direction, you can get away with it. It's fine. But the moment you turn the skew over to either make a bead or something else, that burr is going to get in the way and it's going to create a problem. So it's the only tool that I carry a little credit card diamond sharpener in my pocket. And when I'm all done with a skew, sharpening a skew, I take it once and I go. And that's it. Any other questions?
Okay.
Again, I got an M on my badge, which means mentor. So if any of you need some help, even over the phone, just give me a call or I'm happy to come to your shop.
Okay, what I want to say regarding the blocks, I'm going back to the blocks again. I wrote up some instructions on how to create these blocks.
Oh, great.
So what I will do is send those instructions to Spence, let him check the instructions for accuracy and make sure that I got them right. And then we can send them out to the rest of the club. Does that sound like a good idea? Okay.
I tell you
So-
guys, if you try, this sounds like a kind of weird thing to do, but if you try it, I guarantee the first time you'll be a devotee.
Right. So I'll put that on my list and Spence can check them out. Any other questions for Spence? Okay.
Did I cover
nice.
the subject okay?
Yeah, perfect. I want to remind everybody that Spence is going to be doing a follow-up at Dean Humphrey's workshop, March 11th. So bring your tools and maybe even more hands-on.
Yep.
He can show you all those angles. We didn't turn the grinder on today because, well, we did? Quiet. Okay. Okay. That concludes our meeting. So thank you, Spence.
You're welcome.
Thank you very much.
Balanced.
Oh, that's right.
Oh, what are my little containers?